All right, so let's check out practice 5.3. And it wants us to find all 6 trig functions given this ordered pair, this point on the graph. So let's figure out where that is. So x is minus 7, which I'll say is right there somewhere. And y is 24. So our point is right here. And here is our terminal. So this is our standard angle. And then this right here is our reference angle. And we draw this down to the x-axis. And there is our right triangle in the second quadrant. And let's take it off the coordinate system for a moment. And so if we look at the adjacent leg, so adjacent, I should say adjacent to the reference angle here on the x-axis, remember minus 7 is the position, but the overall length here is 7. And then it has a height of 24. And then to get the hypotenuse, we would just use Pythagorean theorem. And once we have all 3 legs, we can get all 6 trig functions. So let's look at sine of our standard angle. So sine is y over r. So y is 24, and that's positive, and the hypotenuse is 25. Cosine is x over r. Now x, remember these x's and y's always refer to the coordinate system. So in our coordinate system, x is minus 7, and the hypotenuse is 25. And for tangent, which is y over x, well, if we look at y is a positive 24, and x is a minus 7. Now to get the other 3, remember the other 3 are just reciprocals of these. So cosecant is just the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. And so we have all 6 trig functions. All right, so I'm entering the last answer in. I already entered the other 5. And that is question 1. All right, so we want to know what happens at these quadrantal angles. So that's the angle, the axis angles here. And so this is 0 degrees, 0 radians. This is 90 degrees, which is pi over 2. This one over here is 180 degrees, which is pi. This is 270 degrees, which is 3 pi over 2. And then getting back in 360 degrees, 2 pi. So sine of 3 pi over 2 is this standard angle. And remember, what we're doing is we have, or we can think of it this way, we have some arrow, and we're saying this arrow has length r. And this arrow, we rotate through our angle. Now, the length of the arrow doesn't change. So as we rotate this arrow through, it's the same length, but now it's pointing this way. And notice that there's no x component. The arrow points straight down, and it's all in the y direction. So this arrow, which has length r, must be ending at a point right here where y equals negative r, because we're in a negative number direction here. So if we look at sine of 3 pi over 2, and remember sine is y over r. Well, if we look at this case, y is minus r. And so sine of 3 pi over 2 is minus 1. Now, this is a good problem. And the random number generator might do a few different things here. So let's try a different one of these. And let's say this time we're going to be interested in cosine pi. So pi means we have this standard angle. And again, try to imagine an arrow of some length r, and we rotate this arrow through this angle, and this arrow is now lying flat again over here. And the arrow is still the same length. The arrow doesn't change length. And notice the arrow has no y component to it. It's completely in the x direction. And so this x value right here must be minus r. And the y value here is 0 because it's laying flat. Now cosine, we know, is x over r. And by looking at this rotation of this arrow, x is minus r. And so cosine of pi is minus 1. And just real quick here in this, what about sine of pi? Well, we know sine is y over r. And if we look at what we've determined, y is 0 when we do this 180 rotation. And so we'd have 0 over r, which is 0. So just a few more examples there of number 2. Oh, and we do have some more examples of this one. Now we have a tangent, pi over 2. So let's check that out. So pi over 2, 90 degrees. This is our standard angle. So our arrow starts in this position and rotates, and now it's up here. Now notice the arrow now, there's no x position here. It's all in the y. And so y equals r. So for tangent, of pi over 2, which is y over r, y over x. Let's look at our information. Y is r, and x is 0. And now in this case, we have division by 0, which is undefined. So this expression is undefined. And we'll see more of the tangent function. But the tangent function looks like this. And at 90 degrees, it has a vertical asymptote. It is not defined at 90 degrees. So we want to name the quadrant that this angle is in that satisfies these two conditions. So let's draw our coordinate system. And let's look at the first condition, that tangent has to be greater than 0. So let's look at these quadrants here. Now remember, tangent is y over x. So let's look at quadrant 1. In quadrant 1, so think of a right rectangle in quadrant 1. X is positive and y is positive, which means a positive number is greater than 0. So this is true in quadrant 1. Tangent is greater than 0 in quadrant 1 because x and y are positive numbers, and a positive number is greater than 0. Now if we look at quadrant 2, again, think of our right rectangle that's here, right triangle. Now in quadrant 2, x is negative and y is positive. So a positive divided by a negative gets us a negative number. So region 2 is false. It's less than 0. If we look at quadrant 3, think of a right triangle here. In quadrant 3, we have a negative x and a negative y. And a negative divided by a negative is positive. So tangent is positive in quadrant 3. Then finally in quadrant 4, x is positive and y is negative, which should mean tangent is then negative. So we know this is true in quadrant 1 and 3. Now what about secant? Remember, secant is the reciprocal of cosine, and cosine is x over r, and so the reciprocal of that is r over x. Now r is always positive. So to find when secant is positive, we just have to look at our x values. So we can see x is positive in quadrant 1, and x is positive in quadrant 4. Now, when are both of these statements true? Well, both of these statements are true when you're in quadrant 1. Find the reference angle for 317. So as you can see from this point, starting with the coordinate system, pretty much the first step. Always a good to have a picture. So 317. So this is 270, 360. So we know 317 is going to be in quadrant 4. And we want to find the reference angle. So quadrant 4 means a quadrant 4 right triangle. So we always draw the line to the x-axis, which means we're looking for this angle here. That's the reference angle. So this whole angle here is 317. So to find this difference, we just do 360 minus 317, and we'll find this is 43. And that is our reference angle. It's the interior angle of our right triangle. Oh, well, the random number generator not giving us too much variety here, because 341 is also in the fourth quadrant. So we'll draw our right triangle. There it is, a fourth quadrant. We want to figure out what the interior angle here is, the reference angle. And to get that, we'll do 360 minus 341 to get 19. All right, so number 7, again, so I'm adding a new take here for number 7, since my last one I thought got pretty messy. And it has to do with our angle is now a fraction. And to compare fractions, they all need the same denominator. So if we look at our access points here, in radians, this is 0 radians. 90 degrees up here is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 is 2 pi. So what I did in my last explanation is I changed everything here to the same denominator. And that's actually, a little bit of work, get a little messy. But in thinking about it, that's not how I actually do it. I don't actually convert all these things. What I do when I'm looking for these fractional angles is I first look at pi. I want to first determine if it's above or below, because that automatically then eliminates two choices. And why pi? Because pi is easy to deal with when you have a fraction. Because to compare these two numbers, we just have to multiply this by 11. And so right off the bat, we can see 6 pi is less than 11. And so we've eliminated quadrant 3 and 4. We know 6 pi or 11 has to be in 1 or 2. And now, the only fraction that we need to compare is pi over 2 now. So to get a common denominator between pi over 2 and 6 pi over 11, we'll have to multiply this by 11 over 11. And this by 2 over 2. And so we can see 12 pi is larger than 11 pi, which means then this angle is in quadrant 2. Now this particular problem is actually asking for the reference angle. And so the reference angle is the interior of our right triangle. So remember, you draw down to the x-axis. Here is our reference angle. And so our reference angle is going to be 11 pi over 11, because that's a full 180 rotation, minus the angle we're given, 6 pi over 11. So that's this angle here. So 11 pi over 11 is right here, and 6 pi over 11 is right here. So we can just subtract those to get what the reference angle is right here. So we'll start with our coordinate system. Minus 340. So here is minus 270. So we need to go another 70 degrees to get to our terminal. And there is minus 340 degrees. So we'll, from our terminal, draw to the x-axis. That creates our right triangle that we're using. And the interior of that right triangle is our reference angle. So this is minus 340. We know this is 360. And that difference then is 20. Another reference angle, 760. Oh, here's what I was hoping for. Something that's got some revolutions in it. So one revolution is 360. So that means we need to go another 400. Now, another 400 means another 360. And then plus 40. So 360 plus 40, 400. And so our final angle, our terminal, is in quadrant 1. And this angle, so remember, draw our line down to the x-axis. Here's our right triangle. And the interior angle here is the reference angle, 40 degrees. So now we're going to use reference angles to get the exact answers here. And they're saying do not use a calculator because your calculator will give you the decimal number. And we want the exact fraction here. So we'll start with our coordinate system. And we'll look at what quadrant we're in. So 120 is over here in quadrant 2. So here is our right triangle. And it has an interior angle, a reference angle of 60 degrees then. So we'll just take a moment and look at this right triangle. And we're being asked about cosine. So what do we know about cosine? So cosine is the function that decreases from 0 to 90. And that puts cosine 60 at a half. Cosine is also x over r. So that means we can assign 1 to the x position and 2 to the hypotenuse. And now we'll take our picture and put it back onto the coordinate system. So our hypotenuse is 2, but this leg on our coordinate system is -1. And so when we look at cosine of 120, which is x over r, we have x is -1 and r is 2. So cosine 120 is -1/2. So we got tangent of 780. So again, I keep saying again, because this is almost always the first step, draw the coordinate system. And let's find out what quadrant our angle is in. So 780 degrees. And you want to think in terms of 360. You want to think in terms of revolutions. How many revolutions are here? So we can see there's definitely at least one revolution. And there's actually two, because 360 plus 360 is 720. 720 means we would have 60 more to go then. So 780 is one revolution plus another revolution plus 60 degrees. So we'll go around once, go around twice, and then 60 degrees is our terminal. Now this swirly pattern here, this is the standard angle. The swirls here, that's the standard angle. This, remember, the right rectangle that's formed, the interior angle is the reference angle. And that reference angle is 60. So we'll take our right triangle. I don't know why I keep saying rectangle so many times for that. And we're looking for tangent. So we know tangent is sine over cosine. And sine of 60 is square root of 3 over 2. Cosine of 60 is 1/2, which means we get square root of 3. And remember, this is square root of 3 over 1. And tangent is also y over x. And so going back to our picture, y is square root of 3. And x is 1. We'll now take our picture and put it back onto the coordinate system. So on our coordinate system, square root of 3 is still positive on our coordinate system. And side 1 is also positive on our coordinate system. And so now we can do tangent of 780. Because we know tangent is y over x, and we've just concluded y is square root of 3 and x is 1. So tangent 780 is square root of 3. I'm actually just curious if it takes this shorthand. It does take shorthand. Cool. So find another value using reference angles. Got a cosecant here. And let's look at what quadrant we're in. So we got 5 pi over 4. And you want to check pi and 2 pi. Now pi, getting a common denominator here, is 4 pi over 4. And getting a common denominator with 2 pi would be 8 pi over 4. So you can see 5 is between 4 and 8. So 5 is definitely in quadrant 3 or 4. And then we'd have to check 270, which is 3 pi over 2. We have to get a common denominator. So multiply this by 2 over 2. And so we can finally see then, if this is 4 pi over 4 and 6 pi over 4, then 5 pi over 4 is in quadrant 3. And there is our standard angle. So we have a third quadrant, right triangle. And if this is 5 pi over 4, so this is 5 pi over 4, and this is 4 pi over 4, means the difference here is pi over 4. That is our picture then. So pi over 4 is 45 degrees. And we're being asked for cosecant. Remember, cosecant is the reciprocal of sine, and sine is y over r, and so the reciprocal is r over y. We also know what sine pi over 4 is. It's one of the things you're supposed to memorize from that table in the last lecture. Sine of 45 degrees is square root of 2 over 2. And the reciprocal of that is 2 over square root of 2. So r we can write as 2, and y we can write as square root of 2. So looking at our picture, r is the hypotenuse. We're going to say that's 2. And y is square root of 2. So now that we have our picture, we'll stick it back to the coordinate system. So the hypotenuse is 2, but y is in the negative direction, and so we would write this in as a negative square root of 2. And so when looking for cosecant of 5 pi over 4, we know cosecant is r over y. R is 2, and y is minus square root of 2. Now, MyMathLab says here to rationalize the denominator. And that specifically means you can't have any square roots in your denominator. So to get rid of this square root, we multiply by 1. And by 1, we define that to be square root of 2 over square root of 2. This will rationalize the denominator because square root of 2 times square root of 2 is just 2. And in the numerator, then, we have 2 square root of 2. And all of this is negative. So this is the answer MyMathLab is looking for when they say rationalize the denominator. So this is a perfectly fine answer. 2 over square root of 2 is perfectly fine. But MyMathLab is specifically stating to rationalize the denominator, which means they want this one. get rid of all square roots in the denominator. Well, that's humorous because there's an obvious cancellation there that I completely missed. 2 divided by 2 cancels out, and we're just left with square root of 2. And there we go. So sine of minus 210. And as always, our coordinate system. Let's figure out where minus 210 is. So this is minus 180, which means we've got to go 30 more. And here is our standard angle. Rotating in the negative direction here. We'll look at our terminal side, draw to the x-axis. This gives us our right triangle here. The interior angle of this right triangle is the reference angle. And we can see that's 30 degrees. So we'll take a look at this right triangle with it off of the coordinate system for a moment. And we're being asked about sine. And so we're going to think to ourselves, well, what do we know about sine 30? Sine 30 is a half. Sine is also y over r. So we can identify r as 2, y as 1. Well, now I'll take our picture and put it back onto the coordinate system to see if we need to assign any negative values here. So on our coordinate system, the hypotenuse is always positive, and 1 here is also positive. And so now we have our y and r for sine of minus 210. Y is 1, r is 2. Okay, so after going through the random number generator a little bit, here's a crazy looking one. So the random generator will choose a different trig function as well as angle here. So who knows what combination you could get here. But this one looks pretty crazy. That might scare you. So let's check this one out. And we want to first deal with how many revolutions are in this angle. We have 360, 720, and now if we add another 720 to 360, we'd get too much. So if we take 1035 and subtract off 720, we've got 315 left. So 1035 is 2 full revolutions and then 315 more. So this is 45 degrees short of another revolution. So we have 1, 2, and then almost 3. So here's our right triangle. And this interior angle here, the reference angle, is 45. So we'll take a look at this. And we're being asked for secant. So we know secant is 1 over cosine. And cosine is what you should remember from that table. Square root of 2 over 2. taking the reciprocal of this is 2 over square root of 2. And we also know secant is r over x, the reciprocal of cosine. So we can identify the hypotenuse as 2 and the x distance as square root of 2. We'll then take our picture, put it back onto the coordinate system to see if any of the numbers change sign. And they don't, because this leg is in the positive x direction. And so we have our numbers. So if we look at secant of 1035, which we know is r over x, and we have r is 2, and x is square root of 2. Now, MyMathLab does again say rationalize the denominator. And so that means we got to get rid of the square root. We do that by multiplying by square root of 2 over 2. And so we'll get 2 square root of 2 over 2. And I won't forget this time that these 2's will divide out to get square root of 2. And that is practice 5.3.